Hello, Laracon. Okay, let's go. This is so good to be here at Laracon India. This is actually my first time here in India, and I'm having such an amazing time so far. I'm really excited to be sharing this weekend with you all. Now, as you've just heard from that introduction, I'm from London in the United Kingdom, and you might have heard a British stereotype that we love to talk about the weather. And yeah, it's true. When I left for London, it was 6 degrees. It was freezing cold. And then when I got off the plane here in India, lovely and warm. I'm really, really enjoying the weather here. Now, I also love to learn new languages. So as you heard, I'm learning Spanish. But I've also been trying to pick up a couple of Gujarati phrases. So let me give this my best shot. Kim Cho. Hey! Nice. Now, over in London, I work as the head of engineering for a software company called Trybe, and we make software for spa hotels, and that helps them manage their reservations, inventory, customers, memberships, and staff, all from a beautiful Laravel application, and this is my team. Now, I've been writing Laravel code for about 10 years now, starting back in 2013 with Laravel version 4.2. Anyone remember 4.2? Yeah, nice. Now, I love writing Laravel code, but I also just love tech in general. I love giving myself a challenge and learning something new. So recently I've been learning Apple's programming language Swift for writing native iOS applications, and a couple of my apps are actually on the App Store today that you can download, including Sneezy. This is an application for tracking patterns in how often you sneeze. What can I say? I'm a data nerd, I love data. Now, I've also been dabbling with the programming language C, where I've been having a go at writing PHP extensions. And Mickey Hoffman here did a great talk on an introduction into writing PHP extensions back at Laracon EU last month. That's on YouTube, highly recommend checking it out. Now, I've also spent the past few years tinkering with microcontrollers and building various home automation projects in my free time. Like this one here. This is a self-watering plant project, so this automatically waters my plants at home, which is great because I always forget to water my plants and they die, but not with this project. Now, one device that I love to work with is this little thing here. This is called an ESP32. Now, these chips are used by a ton of different vendors to provide home automation functionality, and they're used for things like smart bulbs, smart plugs, and the great thing is they're really cheap. And they come with lots of capabilities built in, like Wi-Fi and Bluetooth. But most importantly, these chips have these things called GPIO pins, General Purpose Input-Output. Now, this is what allows us to programmatically control voltage to connected peripherals. Now, what does that mean? Well, in simple terms, it means two things. First off, it means that we can programmatically turn something on or off. Now, this is pretty much the basis for how electronics work. We connect up our peripheral to a GPIO pin, and then we write code to tell it whether it should be turned on or off. Now, this is what allows a smart bulb to be turned on or off. This is also how we control traffic lights. They're controlled by GPIO pins. But it's also how we control more complex hardware. Now, digital devices like this thing here, this is an LCD screen, these things receive their instructions in the form of binary. And we do this by turning on and off different wires in a specific sequence. Like this. So that's the output side of the GPIO pin. But let's not forget, there's also the input side. Now, this is the ability to read how much voltage something is sending us. Like a soil moisture sensor that I used in my plant watering project. So this thing will send us a lower voltage when the soil is dry, and then when the soil gets wet, we get a higher voltage. So we can use that to determine how moist the soil is. Now, ESP32s are great. I use them for so many things, and they're used by so much of the industry. But they have one massive downside, and that downside is that they have very limited resources. We're talking 520 kilobytes of RAM. And now, when you're working with such limited resources, your code that you write on it has to be much closer to machine code. You usually have to write in C. They just don't have enough resources to run a modern programming language like PHP. Now, let's look at another device. This one here, the Raspberry Pi. Anyone familiar with the Raspberry Pi? Yeah, nice. I love these things. So for those who aren't familiar, the Raspberry Pi is a credit card-sized microcomputer. So these things are quite affordable. I think they start at around 2,000 rupees. And they have lots of capabilities built in, including Wi-Fi, and up to 16 gigabytes of RAM. So these things are perfectly capable of running PHP. They actually run on Linux, so we can run all of the tools that we're familiar with. But most importantly, these chips have 40 GPIO pins. That's 40 different things that we can programmatically turn on and off, or 40 different things that we can programmatically receive input for, or we can mix it all together to build some really cool project. Now, this gave me an idea. How cool would it be if we could interact with hardware, not by writing C, but within a Laravel application? Now, we've already seen some really great innovations in PHP recently. We've had Laravel Herd revolutionizing our development environment. We've had Livewire allowing us to build interactive interfaces with just PHP. We've had Laravel Reverb allowing us to make those interfaces real-time. We've got Inertia allowing us to glue our front end and our back end together. And then we've got native PHP that allows us to build desktop applications with just PHP. And as we recently heard from Simon Hamp at Laracon EU, we've now got the ability to do iOS applications with that. So you might be wondering, what's next? Well, I would like to join the mission in stretching the boundaries of what's possible with PHP. So today, I would like to introduce you all to Pinout, a library that I built for Laravel that lets us easily interact with hardware using the framework that we know and love, Laravel. Now, the premise is simple. Oh, thank you. The premise is simple. We connect our peripherals up to a Raspberry Pi, and all of our code runs on the Raspberry Pi. Now, more than 15 models of the Raspberry Pi are supported, and you can use all of the Laravel functionality that you're familiar with. So that means that you can interact with hardware from a HTTP request, from an event, from a scheduled task, even inside an artisan command. And we're not just talking about turning things on and off as well. Pinout comes with drivers to drive hardware for common pieces of hardware. So we're talking about LEDs, 7-segment displays, LCD displays, and plenty more to come. Now, this is open source and it's available on GitHub. So I'm going to be showing you how it works. But first off, let's talk about some equipment that I'll be using for these demos. So, first off, this thing here is called a breadboard. For those who haven't delved into electronics before, a breadboard is a reusable device that lets me build a quick prototype circuit without needing to do any soldering. Now, these things are great for putting together quick prototypes, so I'm going to be using them for most of the videos today. Now, the next piece of equipment is this. This is the Raspberry Pi. For most of the demos, I'm going to be using the Raspberry Pi 3 Model A+. But as you just heard, more than 15 models of the Raspberry Pi are supported. And now these things here, these are the GPIO pins for our Raspberry Pi. Now what I'm going to do is I'm going to connect up all of those GPIO pins to my breadboard using this device here. This is called a cobbler. These are really cheap, and they're great for prototyping. So there we go. Plug that into my breadboard. Now, I'm going to piece together a really basic circuit. This is just going to be an LED. I've got a resistor in there as well. A resistor is standard practice whenever we're working with LEDs, and it's to make sure that we don't draw too much current and blow the LED. Now, in this circuit, I've got two wires. One of them is pointing to ground, and the other one, I'm pointing it to a GPIO pin. Now, all of these GPIO pins are labeled, and I've connected this one up to pin number 21. Now, pin number 21 is currently programmed to be off, so that's why when I put the circuit together, the LED is off. Let's change that. I'm going to be connecting up to my Raspberry Pi using the fantastic Tinkerwell application built by the Beyond Code team, so we can connect up over SSH. And I'm going to use that to write some lines of code and run the PHP on it. Now, I've made a brand new Composer Laravel project, and I've Composer required the pinout library here. And I'm going to use the pin service facade in the pinout library to get a reference to pin number 21. Now, once we've got that reference, we can use the turn on method, and we'll give that a run, and there we go, bam, the LED turns on. Pretty cool, right? And then we can do turn off, give that a run, and the LED turns off. Nice. Now, okay, I know what you're thinking here. Why? Why would anyone want to do this? Who wants to turn LEDs on and off from a Raspberry Pi on a breadboard? Okay, fair point. Well, first off, this basic example opens up the path to a bunch of solutions that you can build. Because let's not forget, Pinout is just a regular Laravel package. So you can interact with these pins anywhere where you want in your application. Secondly, your projects don't need to be on a breadboard like that thing that I just showed you there. You can make more permanent projects by soldering your things onto a board and then housing everything together in a nice little box. And if you've got a 3D printer, then yeah, you've got a lot of fun there. So let's build a real-life solution together. Now, at work, we use GitHub Actions to run tests and deploy our platform. So that means that I find myself having to keep an eye out for this tiny little icon here on the GitHub website to find out whether my build has succeeded or failed. You might be able to see where I'm going with this. I want to build something that I can keep on my desk that has LEDs that indicate the current build status, so I can always see my latest build status at a glance without having to look for that tiny little icon. And we can build just that with Pinout. And it's super simple. Let me show you how to do it. Okay, before we jump into any code, let's plan the hardware side of it first. So first off, for this project, I'm going to need 3 LEDs. I'll need a red, a yellow, and a green one. So these will be used to indicate the status. I will also need some resistors because I'm working with LEDs, so I don't want the resistors to draw too much current. And then finally, as I mentioned, this is going to be a permanent project. We don't want to do this on a breadboard. We want this to be a permanent thing. So we're going to use a piece of board instead, and we're going to use a soldering iron to solder all of the pieces together. Okay, next, let's have a little think about the code. So we're going to use GitHub's API to determine the build status of a given repository. Now, there's 2 ways of doing this. The first way is we could do polling. We could set up a scheduled job using the Laravel scheduler to run at a certain frequency to poll the API to determine what the current build status is. That would work, but that's not great. That means that I have to worry about things like GitHub API rate limits, and it also means that my status monitor isn't going to be super up to date. So we're going to do this properly. We're going to use GitHub webhooks. This means that we're going to be asking GitHub to send our Pi a HTTP request every time when the status updates. Now you might be thinking, whoa, how are we going to do that? Our Pi doesn't have a public IP address. What website do I put in when I'm defining the webhook? Oh, don't worry, I got you covered. Well, sorry, I should say the Beyond Code team have got you covered. We're going to be using this tool called Expose. This is a tunnel application, and it allows us to make inbound connections to a local environment. You might have heard of another application that does a similar thing called ngrok. This is pretty much the same, but this is built with PHP. So let's install Expose onto our Raspberry Pi, and we're going to run Expose to expose our development environment, and we get the shared URL back. So that URL, we can use that to access our environment on our Pi. Okay, now let's go into GitHub, and we're going to create a new webhook on the given repository, and I'm going to pass in my expose URL. I'm going to scroll down, and I'm going to pick this one. I want to enable the webhooks for the workflow runs event. So that means that GitHub will only send me a webhook whenever anything to do with a workflow run updates. Okay, now let's jump into some code. I've got a brand new Laravel application here, and I'm going to do a composer require for the pinout library. And also worth mentioning here, the code, because it lives on the Raspberry Pi, for a quick development experience, I'm going to be using the VS Code remote adapter. And this allows us to write code on our own laptop without having it connected to our Pi. So as long as the Pi is connected to the internet, then we can use the VS Code remote adapter to access that. Now, let's make a new controller. I'm going to call this the GitHub Webhook Consumer Controller. And this is where all of our logic is going to live. Usually I wouldn't do that, but just for the simplicity of the demo, we'll put everything in the controller. Okay, let's make this a bit bigger. So the first thing that I want to do is I need to store a reference to my pins. So I want a reference to the green LED, sorry, the red LED, which is on pin 13, the yellow, which is on 14, and the green, which is on pin 15. So just like before, I'm using the pin service facade, passing in the pin number, and then we get a reference to that pin, so we can call the methods on there to turn them on and off. Now, before we go any further, let's jump back to the API documentation real quick. After looking at the docs, I know that I'm going to receive a lot of information about the latest job, but the keys that I'm particularly interested in are these two ones here, the conclusion and the status. This tells us what the status of the latest job is. So let's go ahead and add some logic to our consumer. Now, pinout comes with a collection class that allows us to interact with multiple pins in one go. So the first thing before I write any more logic is I want to reset the state. I need to turn off all of the LEDs. So here I've instantiated a pin collection class. I've passed in each pin reference, and then I'm calling turn off to turn them all off in one go. Now I'm going to pass in the request parameter so that I can access the payload of what GitHub has sent us. And I'm going to build up an array here of all of our pending statuses. So that's requested, in progress, queued, pending, and waiting. If the status that GitHub reported to us was any one of these, then that means that we should turn on the yellow LED. So it's as simple as this. We've got an if statement, we use that reference, and we call the turn on method. Next, we want to check to see if the status was completed, then we need to look at the conclusion parameter to work out what the conclusion was. It might have completed, but it failed, or it might have completed and it was successful. So if the conclusion states that the job was a success, then we'll illuminate the green LED, all good. But then if it's anything else, we'll just turn on the red LED. Nice. Okay, so that's all we need for our first basic version. So let's go ahead to our routes file, and we'll define that route. Now, it's worth mentioning here, if you're building this at home, you're probably going to want to add in some signature validation or some kind of security to make sure that someone can't tamper with your piece of hardware. But for the simplicity of this demo, we'll just keep that out. Okay, now, because I mentioned this is a permanent project, I don't want to be using a breadboard, so this is me soldering all of the pieces together. And there we go, we get our completed board. Lovely. Now I'm actually going to be using a different model of Pi for this one. I'll be using the Raspberry Pi Zero. The reason for that, this one is much smaller, so it's perfect for permanent projects because you can tuck it away nicely. So let's plug everything in and give it a quick test. So here it is. I haven't got a box for it, but this is my piece of hardware. And we can see that all the LEDs are currently switched off. So let's go ahead and make a change to our application. And we're going to break things. We're going to make our tests fail. So I'll do a commit to say that I broke things, and then I'm going to go and push that up to GitHub. Now, when we push that up to GitHub, we can now see that the orange LED gets illuminated to indicate that there's something in progress. And then we get the red LED to say, well, it's broken. Okay, now let's go ahead and fix that. So I'm going to go back into my code here, and I'm just going to do a fix bug. I wish bugs were that easy to fix in real life. We'll push that up, and then we can see we get back to the yellow, and then eventually GitHub is going to report to us that it was a success, and we get the green LED. Perfect. So this thing is great, and I've actually been using this for some of our repositories at work, and it's really handy. It does save a lot of time just being able to see instantly the status of the repository. Next, I just need to buy a 3D printer so I can get a nice little box for it. Now, this simple project proves to us that us PHP engineers are capable of building hardware projects now. And it's also worth mentioning that we're working with very low voltage for these particular projects. This is just 3.3 volts, so you don't need to worry about getting shocked. Now, working with electronics, building circuits, soldering, all of these things, I know they might seem quite daunting, but there's nothing to be scared of. There's so much content out there online to help you get started on your journey, and the pinout documentation also walks you through some sample projects, so you can get started in no time. Okay, now playing with LEDs, that's quite cool, but pinout can do so much more than that. As I mentioned at the start, pinout includes some drivers for powering some common hardware. Let's have a look at the mighty 7-segment display. Anyone know what one of these is? No, you might not realize it, but these are used so much in our day-to-day lives. Everyone's seen these somewhere. The module is made up of 7 segments, and that can be used to render a digit from 0 to 9, just by turning on and off the different segments. Now let's go back to our breadboard, and we're going to piece together a circuit using one of these 7-segment displays. Now, as I mentioned, because we're working with LEDs, we've got our resistors in line here, and then for each segment, I've connected that up to a GPIO pin on the breadboard. Now, pinout lets us easily render a number on one of these 7-segment displays. So let's go into Tinkerwell, and we're going to instantiate the 7-segment display driver. Now, in order to instantiate the driver, we simply pass in a pin reference for each pin that we're using. Now, I've wrote a quick for loop here that iterates from 0 to 9 with a sleep in there. And then when we run that, we can see we get this. This is just powered from PHP, and we're able to render numbers on that. Now, we've also got support for modules of 7-segment displays, so you can display bigger numbers with even less wiring required. Now, this module contains a chip at the back, and the pinout driver sends it byte sequences in binary in order to display numbers. So I've initialized my driver here just by passing in the pins that I've got connected to it, and I've wrote a for loop here that just iterates upwards and displays a number, and bam, we can see that we're getting these numbers outputted here. So thank you. So I think this is a really great point as well, just to show you how fast pinout is. This is just incrementing up, and we're seeing those numbers be displayed there. So if you're thinking that PHP is too slow or too inefficient to drive hardware, well, yeah, think again. And I'm currently working on some more improvements to make this even faster. This isn't as fast as I'd like it, so we can get there. Okay, let's clear this away, and we're going to look at another piece of hardware. This piece is my favorite. This was by far the most complex driver to write for pinout, but I'm super pleased with the end result, and I think you will be too. So this here is an LCD matrix display. You can pick these up for really cheap, under $1 on AliExpress, and we can use these to output text, numbers, and even symbols. Now, I've wired this up to the Pi using the GPIO pins. I know that that looks quite complicated. Don't worry, it is quite simple. In the pinout documentation, I walk you through exactly what we're doing and how to do it, so you'll be able to join in. Okay, let's plug the Pi in. And we see the default output here. This means that the LCD screen is ready to be programmed. Okay, so we're going to jump back into Tinkerwell. And we're going to instantiate the LCD1602 driver. That's the name of this piece of hardware here. And in order to instantiate it, just like before, we're going to pass in the pins that we've wired into it. Now, we're going to call the initialize method on this, and we're going to use the write string method to output a string to our LCD display. And when we run it, bam, we get text printed on our LCD display driven by PHP. Pretty cool. Being able to output text on an LCD screen just by writing Laravel code is a pretty big deal, I think. It opens up so many possibilities for things that we can build. Okay, that was pretty fun. But everything you've seen so far is just us outputting things to hardware, which is great, but that only gets us so far. Hardware becomes really exciting when we combine input with the output, when we use sensors and we use the output to display the values of that. And of course, Pinout can do that. We actually have 3 different ways of receiving input using Pinout. And each method has a slightly different use case. So the first one is we can use the isOn and isOff methods on the pin class to determine the state of it. So this is especially useful for things like switches. Let's say if you have a switch and you want to programmatically determine whether that switch is on or off, you can use the isOn and isOff methods. Now the second method, and this one is really useful, we can call methods on the driver. So if the pinout driver is for a piece of hardware that deals with input, then the driver will have a method on there for receiving that input. A perfect example of this is a soil moisture sensor. So here I'm instantiating my soil moisture sensor driver, and I'm passing in the pin that it's connected to. And I can echo out the get moisture percentage, and that translates the voltage into a percentage, and we get the output here. And then when we make the soil wet, we can see that the value increases when we rerun this code. So that's really handy for sensors. And here's another example of this. So this one is a temperature sensor. I'm going to connect up this temperature sensor to my Pi, and I'll just plug in the GPIO pins like this, and I've also got some power going to it. And then we're going to jump back into Tinkerwell, and we're going to instantiate the driver for the temperature sensor. Just like before, we're going to pass in the pins that we've connected to it. So this one, it's got 2 pins. And then once we've instantiated it, we can call the read temperature method, and then we get the output here. So this is displayed the temperature in 21.37 degrees Celsius. Now the last method of input that we have is by subscribing to changes on a pin. So this means every time when an input pin changes from low to high or high to low, we actually get a Laravel event, a regular Laravel event. Now in the world of hardware, this thing is called a hardware interrupt. But in Laravel, it's so much simpler. All we need to do is write an event listener to subscribe to whenever that changes, and then we can run our code. So this one's really useful for buttons. Let's say we have a project in a permanent enclosure, and we want to do something every time a button is pressed. We want to run some code. Well, we can do this. We can connect the button up to a GPIO pin, attach an event listener, and then run the code. Now, one thing about me is I love pizza. I'm also a little bit lazy sometimes, and I love automating things. So using this third method of input, I was able to build a device where I have a physical button at home where I can press it and it orders me a pizza. And this is thanks to Pinout. It was really simple to build. So it's just a GPIO pin connected up to a button and an event listener that calls the Domino's Pizza API to order my regular pizza. And then it's got an LCD screen to output the current status of the order. Now, these input methods combined with output allow us to do so much. So let's summarize here. Hardware projects are no longer something that's out of reach for us PHP engineers. Traditionally, if you wanted to build real-life solutions like what you've seen today, you would have had to write in C. You would have had to worry about writing event loops, garbage collection, memory consumption, pointers. Well, with Pinout, you don't need to worry about anything like that. Pinout gives you the opportunity to let your imagination go wild. You just wire up your circuit and you do what you do best, write Laravel code. Now, I've got so much more planned for Pinout. I'm working on new drivers, meaning that you'll be able to interact with more hardware. And as I mentioned, I'm also working on some speed improvements. And I'm also going to be putting out some short video tutorials on YouTube so you can get started. Now, follow me on socials to keep up to date with the latest developments of Pinout. And I'm also doing a bit of a prize giveaway today. So I'm going to be giving away a Raspberry Pi and a 32 gigabyte memory card to get you started on your journey to electronics with Pinout. All you need to do is give me a follow on X. You can scan this QR code and reply to this tweet with your ideas for what you will build with Pinout. I really can't wait to see them, and I really hope this talk has been inspiring to you all. I've enjoyed being up here on stage so much, and I can't wait to hear from you all. Thank you very much.
Thank you, Ren. More than 50 people, or maybe more than 55 people asked different questions. But most of the people were so surprised. They felt so happy of seeing a different talk. And they feel that, how did you even think of this idea?
Yeah. It basically started how I mentioned. So I used to play with ESP32s. It was just something where I wanted to challenge myself. I wanted to learn something new. I was interested in learning some C. But C sucks. PHP is great. And I was just determined to make it happen. There were times when I thought, this isn't possible. I kept on powering through, and a lot of my friends and family just believed in me and encouraged me to get there. And yeah, super pleased with the end result, but there's still more to come.
Yep. So may I invite Ashish Dake to come here? He has asked a couple of questions, but one of his question, he's asking which Node MCU you use for your projects. Here is the question, because it's pretty long, so maybe...
Node MCU, so I use, I can't remember the exact part number, but I mostly use the ESP32 or the ESP8266, and that's the development board that has 40 GPIO pins, and I plug that straight into the breadboard.
Yeah, and like, should we prefer Node MCU or Raspberry Pi to use with PHP Laravel?
Yeah, I would recommend a Raspberry Pi initially for Pinout anyway, because yeah, the Node MCU won't have enough resources to be able to run PHP and therefore run Pinout. So for now, Raspberry Pi, but watch this space because I'm working on some crazy things.
And what if the Wi-Fi password is changed then?
If the Wi-Fi password changes, then you will need to get your memory card and change the SSID on there.
Yeah, that needs to be done.
Yeah.
Okay, all right. And one more question, like 2-3 people ask, what about the Spanish, like 1800 days learning Spanish?
Yeah, it's nearly 5 years now. It's crazy.
Yeah, but just like for passion, like you want to learn?
Yeah, I don't really know why. I can't even blame it on lockdown. I started learning before lockdown, but I think lockdown accelerated that. And yeah, I just love it. I love language.
Okay, everyone, then.
Thank you.